Welcome to today's episode on compounds of alkaline earth metals. Let us first learn about calcium oxide or quicklime, represented as CaO. We will begin with its preparation. It is prepared on commercial scale by heating limestone, that is calcium carbonate, in a rotary kiln from 1070 to 1270 Kelvin. Calcium carbonate decomposes to calcium oxide and carbon dioxide. Heat absorbed during the reaction is 179.9 kilojoules. Children, in order to get good yield of quicklime, few precautions must be taken. Let us list them one by one. First precaution is carbon dioxide formed in each reaction must be removed as soon as it is formed in order to facilitate the forward reaction. Now, the second precaution is the temperature in the kiln should not be allowed to rise beyond 1270 Kelvin. Otherwise, silica, that is SiO2, present as impurity in limestone, will combine with calcium oxide. Children, let us now learn about its properties. It is a white amorphous solid which melts at 2870 Kelvin. When exposed to air, it absorbs both water vapors and carbon dioxide to form calcium hydroxide or slaked lime and calcium carbonate. When water is added to quicklime, that is CaO, the reaction is highly exothermic, accompanied by hissing sound. Slaked lime, that is calcium hydroxide, is formed as the product and the reaction is called slaking of lime. When calcium oxide is heated with an ammonium salt, it evolves ammonia gas. Children, let us now learn about uses of calcium oxide. It is used for making building materials such as mortar, cement, etc. It is useful in the manufacture of cement, glass, calcium carbide, sodium carbonate, etc. Children, we will now learn about calcium hydroxide or slaked lime, represented as CaOH whole twice. Let us begin with its preparation. Slaked lime is formed by adding water on quicklime. Slaked lime is a solid mass and its suspension in water is known as milk of lime. The aqueous layer decanted from the milk of lime is called lime water. Children, remember that quicklime is obtained by heating limestone. Slaked lime is formed by dropping water over quicklime. Suspension of slaked lime in water is called milk of lime. Aqueous layer decanted from milk of lime is called lime water. Slaked lime is also formed by heating together calcium chloride and caustic soda. Sodium chloride is also formed in the reaction. Children, let us now learn about properties of slaked lime. It is a white amorphous solid sparingly soluble in water and its aqueous suspension is called milk of lime. When dry chlorine is passed through slaked lime, bleaching powder is formed. On passing carbon dioxide gas through lime water, the solution becomes milky due to formation of insoluble calcium carbonate. When carbon dioxide is passed in excess, the milkiness of the solution slowly disappears because calcium carbonate is converted into soluble calcium hydrogen carbonate or calcium bicarbonate. In case the solution of calcium hydrogen carbonate is heated, the reaction becomes reversible and milkiness again reappears due to formation of calcium carbonate. Carbon dioxide and water are also formed. Calcium hydroxide dissolves in dilute hydrochloric acid and gives soluble calcium chloride and water.
Let us now learn about uses of calcium hydroxide. Calcium hydroxide is used as the building material such as mortar. It is used for the softening of hard water. Lime water is commonly used to detect carbon dioxide. It is used for whitewash, which serves as a disinfectant. Calcium hydroxide is also used for the manufacture of bleaching powder, glass, and ammonia.
Children, let us now learn about calcium carbonate or limestone or marble. Calcium carbonate occurs in nature as limestone and also as marble rocks. It can be prepared on small scale by few methods. Let us discuss them one by one. By passing carbon dioxide through slaked lime in limited amount. Calcium carbonate can be prepared by passing carbon dioxide in calcium hydroxide and upon heating the solution. Water is also formed in the reaction. Excess of the carbon dioxide gas should be avoided as it will lead to soluble calcium bicarbonate. Calcium carbonate can also be formed by reacting aqueous solutions of sodium carbonate and calcium chloride. Sodium chloride is also formed as a byproduct. Let us now learn about the properties of calcium carbonate. Calcium carbonate is a white, fluffy, amorphous powder and is only slightly soluble in water. Calcium carbonate, upon heating to 1200 Kelvin, decomposes to evolve carbon dioxide. It liberates carbon dioxide on reacting with dilute mineral acids. Calcium carbonate, upon reacting with dilute hydrochloric acid, forms calcium chloride, water, and carbon dioxide. Calcium carbonate, upon reacting with dilute sulfuric acid, forms calcium sulfate, water, and carbon dioxide.
Let us now learn about uses of calcium carbonate. Calcium carbonate or marble is used as a building material. It is also used in the manufacture of quicklime. It is involved in solvay process to prepare sodium carbonate. It finds application in metallurgy for the extraction of iron. In completely pure form, it is used in toothpaste and certain cosmetics.
Children, let us now learn about calcium sulfate or gypsum, represented as CaSO4 2H2O. Calcium sulfate occurs both in the anhydrous and hydrate forms. The hydrated form is known as gypsum, and its deposits are located in Rajasthan and also at certain places in Punjab. Let us now learn about its preparation. In the laboratory, calcium sulfate can be formed by the action of dilute sulfuric acid on either calcium hydroxide or calcium carbonate. Calcium hydroxide reacts with sulfuric acid to form calcium sulfate and water. Calcium carbonate reacts with sulfuric acid to form calcium sulfate, water and carbon dioxide. It can also be formed by adding aqueous solution of sodium sulfate to a soluble calcium salt such as calcium chloride. Products formed will be calcium sulfate and sodium chloride. Children, we will now learn about its properties. Gypsum is sparingly soluble in water. Upon heating, its solubility decreases. Upon heating to 390 Kelvin, it gets dehydrated to plaster of Paris, which is CaSO4.5H2O. Upon further heating to 437 Kelvin, it gets completely hydrated to form anhydrous calcium sulfate, also called dead burnt plaster. Children, let us now learn about uses of gypsum. Gypsum is used in the manufacture of plaster of Paris. Anhydrous calcium sulfate is used as a drying agent. Gypsum is used to make blackboard chalks. Children, let us now learn about preparation and properties of plaster of Paris, represented as CaSO4 half H2O. Let us begin with its preparation. Plaster of Paris, as we learned a few minutes ago, is prepared by the partial dehydration of gypsum at 390 Kelvin. Products formed are plaster of Paris and water. Temperature should not be allowed to rise beyond 390 Kelvin in order to check the formation of completely anhydrous calcium sulfate. Let us now learn about its properties. It is a white amorphous powder. When mixed with 3 times of its weight of water, it forms a plastic mass which sets into a hard mass within 10 to 15 minutes. This is known as setting of plaster of Paris. The setting is most probably because of rehydration back to gypsum. During setting, the mass undergoes a slight expansion of about 1% in volume. This helps plaster of Paris to take the shape of any mold in which it is put. We will now learn about its uses. Plaster of Paris is commonly used in making molds for pottery, ceramics, etc. It is also used in surgical bandages for setting broken bones of the body. It is used for making statues, models, decorative materials, and blackboard chalks. Children, let us now learn about cement. सीमेंट एक बहुत ही महत्वपूर्ण मटेरियल है जिस ਦੀ ਵਰਤੋਂ ਬਿਲਡਿੰਗਸ, ਡੈਮਸ, ਬ੍ਰਿਜਸ, ਰੋਡਸ ਆਦि ਦੀ ਕੰਸਟਰਕਸ਼ਨ ਲਈ ਕੀਤੀ ਜਾਂਦੀ ਹੈ। 1824 ਦੇ ਵਿੱਚ ਇੱਕ ਰਾਜ ਮਿਸਤਰੀ ਜੋਜ਼ਫ ਐਸਪਲਿਨ ਲੀਡਸ ਇਨ ਯੂਕੇ ਵਿੱਚ ਕੰਮ ਕਰ ਰਿਹਾ ਸੀ। ਪਹਿਲੀ ਵਾਰ ਲਾਈਮਸਟੋਨ, ਕਲੇ ਅਤੇ ਵਾਟਰ ਦੇ ਇੱਕ ਮਿਕਸਚਰ ਨੂੰ ਗਰਮ ਕੀਤਾ ਅਤੇ ਕੁਝ ਦੇਰ ਬਾਅਦ ਇਹ ਪੱਥਰ ਵਾਂਗ ਸਖਤ ਹੋ ਗਿਆ। ਇਹ ਪੋਰਟਲੈਂਡ ਰੌਕ ਨਾਲ ਮਿਲਦਾ ਜੁਲਦਾ ਸੀ ਜੋ ਕਿ ਇੱਕ ਮਹੱਤਵਪੂਰਨ ਕੁਦਰਤੀ ਬਿਲਡਿੰਗ ਸਟੋਨ ਸੀ ਜਿਸ ਦੀ ਵਰਤੋਂ ਇੰਗਲੈਂਡ ਵਿੱਚ ਉਹਨਾਂ ਦਿਨਾਂ ਵਿੱਚ ਕੀਤੀ ਜਾਂਦੀ ਸੀ। ਉਸਨੇ ਇਸ ਨੂੰ ਪੋਰਟਲੈਂਡ ਸੀਮੈਂਟ ਦਾ ਨਾਂ ਦਿੱਤਾ। ਭਾਰਤ ਵਿੱਚ ਸੀਮੈਂਟ ਇੰਡਸਟਰੀ 1914 ਵਿੱਚ ਹੋਂਦ ਵਿੱਚ ਆਈ। Cement is a greyish fine powder consisting of a mixture of various silicates and aluminates of calcium such as tricalcium silicates, tricalcium aluminate and dicalcium silicate. On mixing with water, it sets into a hard mass with a good strength. Children, let us now learn about composition of Portland cement. Portland cement is a mixture of a number of components and their relative proportions in a good quality cement as shown on the screen. Calcium oxide 50 to 60%, silicon dioxide 20 to 25%, aluminium oxide 5 to 10%, magnesium oxide 2 to 3%, ferric oxide 1 to 2%, sulfur trioxide 1 to 2%. For a good quality, cement ratio of percentage of silica to percentage of alumina should be equal to 2.54 to 4 and ratio of percentage of lime to percentage of silicon dioxide plus aluminium oxide and ferric oxide should be in between 1.9 to 2.1. Let us now discuss about raw materials required for the manufacture of cement. They are limestone. Clay provides both SiO2 and Al2O3 and gypsum. Besides these, small quantities of magnesia and ferric oxide are also needed to impart suitable color to the cement.
Cement manufacturing process. Cement is prepared by dry and wet methods. The dry method is preferred over wet method as it consumes less energy. The difference between the two methods is that the raw material is mixed with water to form slurry, which is fed to a kiln 180 meters long in the wet method. the raw materials are mixed, finely ground, and fed to a kiln 50 meters long. ਆਓ ਇਨ੍ਹਾਂ ਮੈਥਡਸ ਨੂੰ ਇੱਕ ਕਰਕੇ ਡਿਸਕਸ ਕਰੀਏ। ਵਿਦਿਆਰਥੀਓ, ਮੁੱਖ ਕੱਚਾ ਪਦਾਰਥ ਯਾਨੀ raw materials ਲਾਈਮਸਟੋਨ ਅਤੇ ਕਲੇ ਵੱਖ-ਵੱਖ ਖਾਣਾਂ 'ਚੋਂ ਕੱਢਿਆ ਜਾਂਦਾ ਹੈ ਅਤੇ ਫਾਈਨ ਪਾਊਡਰਸ ਲਈ ਵੱਖ-ਵੱਖ ਤੌਰ 'ਤੇ ਕ੍ਰਸ਼ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਡਰਾਈ ਮੈਥਡ ਦੇ ਵਿੱਚ ਲਾਈਮਸਟੋਨ ਅਤੇ ਕਲੇ ਨੂੰ 3:1 ਦੇ ਅਨੁਪਾਤ ਵਿੱਚ ਮਿਲਾਇਆ ਜਾਂਦਾ ਹੈ ਅਤੇ ਹੈਮਰ ਅਤੇ ਟਿਊਬ ਮਿਲਸ ਵਿੱਚ ਕ੍ਰਸ਼ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਫਿਰ ਇਸ ਨੂੰ ਰੋਟਰੀ ਕਿਨ ਵਿੱਚ ਪਾ ਕੇ, ਜਿੱਥੇ ਕਿ ਤਾਪਮਾਨ 1500 ਡਿਗਰੀ ਸੈਲਸੀਅਸ ਤੱਕ ਹੁੰਦਾ ਹੈ, ਮੇਨਟੇਨ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਕਿਨ ਦੀ ਲੈਂਥ 50 ਮੀਟਰ ਹੈ, ਜਦੋਂ ਕਿ ਡਾਇਮੀਟਰ 2.5 ਤੋਂ 6 ਮੀਟਰ ਹੈ। ਕਿਨ ਨੂੰ ਫਾਇਰਿੰਗ ਐਂਡ ਤੋਂ ਹੀਟ ਕੀਤਾ ਜਾਂਦਾ ਹੈ, ਜਿੱਥੇ ਕਿ ਮਿਕਸਚਰ ਮੈਲਟ ਹੋ ਕੇ ਕਲਿੰਕਰਸ ਬਣਾਉਂਦਾ ਹੈ। ਮੈਂ ਤੁਹਾਨੂੰ ਇੱਥੇ ਦੱਸ ਦਿਆਂ ਕਿ ਇਹ ਮਿਕਸਚਰ ਫਾਇਰਿੰਗ ਐਂਡ ਤੇ ਕੋਈ 3 ਘੰਟਿਆਂ ਵਿੱਚ ਪਹੁੰਚਦਾ ਹੈ। ਪਾਣੀ ਪਾਉਣ ਤੋਂ ਬਾਅਦ ਇਸ ਵਿੱਚ ਜਿਪਸਮ ਨੂੰ ਪਾਇਆ ਜਾਂਦਾ ਹੈ, ਜੋ ਕਿ ਸੈਟਿੰਗ ਟਾਈਮ ਨੂੰ ਡੀਲੇ ਕਰਦਾ ਹੈ। ਆਖਰ ਵਿੱਚ ਜਦੋਂ ਇਸ ਮਿਕਸਚਰ ਨੂੰ ਠੰਡਾ ਕੀਤਾ ਜਾਂਦਾ ਹੈ ਤਾਂ ਇਹ ਸੀਮੈਂਟ ਵਿੱਚ ਬਦਲ ਜਾਂਦਾ ਹੈ। ਆਖਿਰ ਵਿੱਚ ਬਣੇ ਸੀਮੈਂਟ ਨੂੰ ਇਕੱਠਾ ਕਰ ਲਿਆ ਜਾਂਦਾ ਹੈ। ਆਓ ਹੁਣ ਵੈਟ ਮੈਥਡ 'ਤੇ ਵਿਚਾਰ ਕਰੀਏ। ਇਹਨਾਂ ਨੂੰ 3:1 ਦੇ ਅਨੁਪਾਤ ਵਿੱਚ ਮਿਲਾਇਆ ਜਾਂਦਾ ਹੈ ਅਤੇ ਫਿਰ ਪਾਣੀ ਦੇ ਨਾਲ ਮਿਲਾ ਕੇ ਪੇਸਟ ਤਿਆਰ ਕੀਤਾ ਜਾਂਦਾ ਹੈ, ਜਿਸ ਨੂੰ ਸਲਰੀ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਇਸ ਸਲਰੀ ਨੂੰ ਸਿਲਿੰਡਰੀਕਲ ਰੋਟਰੀ ਕਿਨ ਦੇ ਅਪਰ ਐਂਡ ਤੋਂ ਦਾਖਲ ਕੀਤਾ ਜਾਂਦਾ ਹੈ, ਜੋ ਕਿ ਲੰਬਾਈ ਵਿੱਚ 18 ਤੋਂ 100 ਮੀਟਰ ਤੱਕ ਅਤੇ ਇਸ ਦਾ ਵਿਆਸ 2.5 ਤੋਂ 4 ਮੀਟਰ ਤੱਕ ਹੁੰਦਾ ਹੈ, ਜਿਸ ਤਰ੍ਹਾਂ ਕਿ ਐਨੀਮੇਸ਼ਨ ਵਿੱਚ ਵਿਖਾਇਆ ਗਿਆ ਹੈ। ਬਰਨਿੰਗ ਕੋਲ ਡਸਟ ਨਾਲ ਕਿਨ ਨੂੰ ਗਰਮ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਕਿਨ ਦੇ ਅੰਦਰ ਟੈਂਪਰੇਚਰ 1100 ਤੋਂ 1800 ਕੈਲਵਿਨ ਦਰਮਿਆਨ ਬਦਲਦਾ ਰਹਿੰਦਾ ਹੈ। ਕਿਨ ਦੇ ਉੱਪਰਲੇ ਹਿੱਸੇ ਵਿੱਚ ਤਾਪਮਾਨ ਘੱਟ ਹੁੰਦਾ ਹੈ ਅਤੇ ਸਲਰੀ ਪਾਣੀ ਦੀ ਕਮੀ ਦੇ ਕਾਰਨ ਸੁੱਕ ਜਾਂਦੀ ਹੈ। ਕਿਨ ਦੇ ਕੇਂਦਰੀ ਹਿੱਸੇ ਵਿੱਚ ਲਾਈਮਸਟੋਨ ਲਗਭਗ 1300 ਕੈਲਵਿਨ ਤੇ ਡੀਕੰਪੋਜ਼ ਹੋ ਕੇ ਕੈਲਸ਼ੀਅਮ ਆਕਸਾਈਡ ਅਤੇ ਕਾਰਬਨ ਡਾਈਆਕਸਾਈਡ ਬਣਾਉਂਦੀ ਹੈ। ਕਿਨ ਦੇ ਹੇਠਲੇ ਹਿੱਸੇ ਵਿੱਚ ਟੈਂਪਰੇਚਰ ਇਜ਼ ਆਫ ਦੀ ਆਰਡਰ ਆਫ 1800 ਕੈਲਵਿਨ। ਇੱਥੇ ਲਾਈਮ, ਐਲੂਮੀਨਾ ਅਤੇ ਸਿਲਿਕਾ ਨਾਲ ਮਿਕਸ ਹੁੰਦਾ ਹੈ, ਜੋ ਕਿ ਕਲੇ ਦੇ ਵਿੱਚ ਮੌਜੂਦ ਹਨ ਅਤੇ ਕੈਲਸ਼ੀਅਮ ਦੇ ਸਿਲਿਕੇਟਸ ਅਤੇ ਐਲੂਮੀਨੇਟਸ ਬਣਾਉਂਦੀ ਹੈ, ਜਿਵੇਂ ਕਿ ਦ੍ਰਿਸ਼ ਚਿੱਤਰ ਵਿੱਚ ਵਿਖਾਇਆ ਗਿਆ ਹੈ। Calcium oxide reacts with silicon dioxide to form dicalcium silicate. Calcium oxide further reacts with silicon dioxide to form tricalcium silicate. Calcium oxide also reacts with aluminium oxide to form dicalcium aluminate. Calcium oxide reacts with aluminium oxide to form tricalcium aluminate. Calcium oxide reacts with aluminium oxide and ferric oxide to form an additional product, tetracalcium aluminoferrite. The resulting mass is very hard and has a grey look. It is called clinker. The clinker is cooled and is mixed with 2 to 3% by mass of gypsum. It is finely powdered and the mass obtained is known as Portland cement. The entire process may be represented with the flow diagram shown on the screen. A slurry of limestone, clay and water is made, which is burnt in a rotary kiln at 1100 to 1800 Kelvin. A mixture of silicates and aluminates of calcium is formed. This mixture is then mixed with gypsum. The result is Portland cement.
Setting of cement. ਜਦੋਂ ਸੀਮੈਂਟ ਦੀ ਵਰਤੋਂ ਕੀਤੀ ਜਾਂਦੀ ਹੈ ਤਾਂ ਇਸ ਨੂੰ ਪਾਣੀ ਦੇ ਨਾਲ ਮਿਲਾਇਆ ਜਾਂਦਾ ਹੈ ਅਤੇ ਜੈਲੇਟਿਨਸ ਮਾਸ ਤਿਆਰ ਕੀਤਾ ਜਾਂਦਾ ਹੈ ਜੋ ਕਿ ਹੌਲੀ-ਹੌਲੀ ਕਾਫੀ ਸਖਤ ਹੋ ਜਾਂਦਾ ਹੈ ਜਿਸ ਵਿੱਚ ਸਿਲੀਕਨ, ਆਕਸੀਜਨ, ਸਿਲੀਕਨ ਸਿੰਗਲ ਬੌਂਡ ਅਤੇ ਸਿਲੀਕਨ, ਆਕਸੀਜਨ, ਐਲੂਮੀਨੀਅਮ ਸਿੰਗਲ ਬੌਂਡ ਦੀਆਂ ਚੇਨਸ ਬਣਦੀਆਂ ਹਨ। ਇਸ ਨੂੰ ਸੈਟਿੰਗ ਆਫ ਸੀਮੈਂਟ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਸੀਮੈਂਟ ਵਿੱਚ ਮੌਜੂਦ ਕਨਸਟੀਟੂਐਂਟਸ ਸੈੱਟ ਹੋਣ ਲਈ ਵੱਖ-ਵੱਖ ਸਮਾਂ ਲੈਂਦੇ ਹਨ। ਉਦਾਹਰਣ ਦੇ ਤੌਰ ਤੇ ਟ੍ਰਾਈ ਕੈਲਸ਼ੀਅਮ ਐਲੂਮੀਨੇਟ ਤੁਰੰਤ ਹਾਰਡ ਮਾਸ ਵਿੱਚ ਸੈੱਟ ਹੋ ਜਾਂਦਾ ਹੈ ਅਤੇ ਇਹ ਸੀਮੈਂਟ ਦੀ ਇੰਟਰਨਲ ਹੈਲਥ ਲਈ ਰਿਸਪੌਂਸਿਬਲ ਹੈ। ਟੈਟਰਾ ਕੈਲਸ਼ੀਅਮ ਐਲੂਮੀਨੋਫੇਰੇਟ ਵੀ ਸੈੱਟ ਹੋ ਜਾਂਦਾ ਹੈ ਪਰ ਇੰਨੀ ਜਲਦੀ ਨਹੀਂ ਜਿੰਨੀ ਛੇਤੀ ਕਿ ਟ੍ਰਾਈ ਕੈਲਸ਼ੀਅਮ ਐਲੂਮੀਨੇਟ। ਆਊਟ ਆਫ ਦ ਸਿਲੀਕੇਟਸ ਟ੍ਰਾਈ ਕੈਲਸ਼ੀਅਮ ਸਿਲੀਕੇਟ ਵੀ ਛੇਤੀ ਸੈੱਟ ਹੋ ਜਾਂਦਾ ਹੈ ਪਰ ਅਸਲ ਵਿੱਚ ਇਹ ਕੁਝ ਦਿਨਾਂ ਬਾਅਦ ਹੀ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸੈੱਟ ਹੁੰਦਾ ਹੈ। ਡਾਈ ਕੈਲਸ਼ੀਅਮ ਸਿਲੀਕੇਟ ਸੈੱਟ ਹੋਣ ਲਈ ਤੁਲਨਾਤਮਕ ਤੌਰ ਤੇ ਜ਼ਿਆਦਾ ਸਮਾਂ ਲੈਂਦਾ ਹੈ। ਸੈਟਿੰਗ ਦੇ ਟਾਈਮ ਨੂੰ ਰੈਗੂਲੇਟ ਕਰਨ ਲਈ ਸੀਮੈਂਟ ਦੇ ਵਿੱਚ ਜਿਪਸਮ ਮਿਲਾਇਆ ਜਾਂਦਾ ਹੈ। Children, let us now learn about cement substitutes. India is one of the major cement producing countries in the world. The cement plants are located mainly in Rajasthan, Gujarat, Himachal Pradesh and at a few more places where the raw materials are easily available. However, the demand of cement is increasing day by day. Efforts are being made to find substitutes of cement. One of them is fly ash, which consists of calcium silicate and is the byproduct of steel industry. This is cheap and is mixed with cement in order to reduce its cost without affecting its quality. Cement is also being made from rice husk, which is rich in silica contents. Biological importance of magnesium and calcium. Children, the ions of magnesium and calcium are also found in large proportions in biological fluids. An adult body contains about 25 grams of magnesium, 200 grams of calcium, 5 grams of iron and 0.06 grams of copper. And they perform a variety of biological functions. Magnesium ions are the constituent of chlorophyll. Calcium ions are the major constituent of our bones in the form of calcium phosphate. The deficiency of these ions occur particularly in old age. They also play an important role in muscle contraction. Both magnesium and magnesium ions act as catalysts in the formation of these linkages. The release of energy due to hydrolysis of pyrophosphate is controlled by calcium ions. Calcium occurs mainly in milk. Vitamin D helps in the deposition of calcium in bones. Children, now that we have learned so much, let me ask you few questions. My first question is, how is calcium oxide prepared on a commercial scale? And the answer is calcium carbonate decomposes to calcium oxide and carbon dioxide. Heat absorbed during the reaction is 179.9 kilojoules. My next question is, how is calcium sulfate prepared? And the answer is calcium hydroxide reacts with sulfuric acid to form calcium sulfate and water. Calcium carbonate reacts with sulfuric acid to form calcium sulfate, water and carbon dioxide. Children, today we learnt about compounds of alkaline earth metals and cement. Hope you enjoyed the lesson as much as I did. Thank you for your kind attention and see you in the next class. Till then, bye.